Volume. Volume is the amount of space occupied by an object. Look at the two objects on the screen, an eraser and a book. Which one takes up more space? Yes, the book. So we say the book has more volume and the eraser has less volume. Remember, bigger objects usually have more volume because they occupy more space. Here is another example. We have a bucket full of water and a water bottle. The bucket is bigger and holds more water, so it has more volume. The bottle is smaller and holds less water, so it has less volume. So again, volume tells us how much space something takes up, whether it's solid or liquid. Now let's compare these two circular objects, a motorbike tire and a bicycle wheel. Even though both are round, the tire is thicker and bulkier, so it has more volume. The bicycle wheel is thinner and mostly with little air inside it, in the tube that you can see along the perimeter of the wheel. So it has less volume. So it's not just the shape but the space inside an object that tells us about its volume. Now that we understand what volume is, let's talk about how we measure it. The SI unit of volume is cubic meter. This cube here shows that it's 1 meter long, 1 meter wide and 1 meter high. So the volume is length multiplied by breadth multiplied by height, which is 1 meter multiplied by 1 meter multiplied by 1 meter equal to 1 meter cube or 1 cubic meter. This is called a unit volume. It's the standard reference for measuring the volume of any object in the SI system. Now, let's apply this idea to real life spaces. Take a look at this room. It's a space that occupies volume, just like the cube. We can measure the room's volume using the same formula. Length multiplied by breadth multiplied by height. And the answer will be in cubic meters. So whenever we want to calculate the amount of space inside a room, we measure its volume in meter cube. Here is another example, a tank. A tank is used to store water and we need to know how much it can hold. This is measured by its volume. We can measure it in cubic meters. Even though the shape of the tank is cylindrical, we still use the volume formula to calculate how much water it can contain. So whether it's a cube, a room, or a tank, the space they occupy is always measured in meter cube. Now let's talk about how we measure volume of smaller solid objects like a brick. Just like the big cube that we saw earlier, we use this formula. Volume is equal to length into breadth into height. And in this case, the dimensions are given 24 centimeters multiplied by 10 centimeters multiplied by the height, which is 7 centimeters. So the volume is 1680 centimeter cube or 1680 cubic centimeters. So we use cubic centimeters for smaller solid objects like bricks, boxes or books. Volume of a liquid. We don't measure liquids usually in cubic centimeters. we use liters. We are more familiar with this unit when we are measuring liquid. So here are some examples. A small bottle of hand wash might hold 250 milliliters. A water spray bottle could be 750 milliliters or even 1 liter. A detergent container might be 3 liters or even 5 liters. So the volume of a liquid tells us how much space it takes up, and we usually write it in liters or milliliters. For smaller amounts of liquid, we use milliliters. Here we can see a measuring beaker. One shows 40 ml and another shows 75 ml. And the flask on the right has 200 ml of liquid. 1000 milliliters, please remember this. 1000 milliliters is equal to 1 liter. So when we are dealing with small quantities, we usually use ml, milliliters. And when we are talking about larger quantities, we use liters. Let's now understand how different volume units relate to each other. We will start with converting cubic meters to cubic centimeters. We know that 1 meter is equal to 100 centimeters. So, 1 cubic meter is equal to 100 centimeter multiplied by 100 centimeter multiplied by 100 centimeter. So that is 100 centimeter cube. That gives us 100,000 cubic centimeters. So 1 meter cube is equal to 10 raised to 6 centimeter cube. Or you can say that a cubic meter is a very large unit and it's made up of 1,000,000 cubic centimeters. Now let's look at something simpler. Milliliters and cubic centimeters. You will be happy to know that 1 milliliter is equal to 1 cubic centimeter. That's right. If you see 100 milliliters of water, it's the same as 100 centimeter cube. Now let's connect liters with cubic centimeters. 1 liter is equal to 1000 milliliters and 1 milliliter is equal to 1 centimeter cube. So that means that 1 liter is equal to 1000 centimeter cube. So 1 liter of any liquid takes up the same space as 1000 cubic centimeters. This helps us switch between solid and liquid volume units easily. Now let's see how liters are converted into cubic meters. We know that 1 liter is 1000 cubic centimeters. And 1 meter cube is 10 raised to 6 centimeter cube. To convert liters to cubic meters, we divide 1000 by 10 raised to 6. So this would give us 0.001 meter cube. So 1 liter is equal to 0.001 cubic meters. This is useful when we deal with large liquid quantities. Now let's reverse the conversion. from cubic meters to liters. 1 meter cube is 10 raised to 6 centimeter cube. You can see 6 zeros here. And 1 liter is 1000 centimeter cube. So let's divide this. 1 meter cube is equal to 10 raised to 6 divided by 10 raised to 3. This gives us 1000 liters. This shows that a cubic meter is a very large unit. It can hold 1000 liters of liquid. Let's find the volume of a cube. A cube has all sides equal. So the formula is volume equal to length multiplied by length multiplied by length. Now let's look at another shape, the cuboid. Cuboid is like a box. It has different lengths, widths and heights. To find the volume of this cuboid, we will use the formula volume equal to length multiplied by breadth multiplied by height. So just multiply all three sides and you will get the volume in cubic units like centimeter cube or meter cube. This formula works for many regular objects like books, bricks and shoeboxes. But what happens when the object is not a regular shape? Look at this rock. It's an irregular solid, which means it has no fixed shape and no easy formula to calculate its volume. So if I ask you, what is the volume of this rock? We don't have any formula for this. So what will we do? Let's find out. For irregular solids like a stone, we use the water displacement method. Of course, the stone we are using is much smaller than the one I showed you in the previous slide. Here is how this water displacement method works. Fill a measuring cylinder with water and note the level. Carefully drop this irregular solid into water. Now what will happen? The water level rises. The increase in water level tells us the volume of the object. So if the water level rises from 150 milliliters to 200 milliliters, let's say, it's less here, but it rises, let's say from 150 to 200. The volume would be 200 minus 150. That would give us 50 milliliters. So this method is very useful in labs and science experiments when dealing with odd shaped objects. Okay, we can say irregular objects. So increase in volume provides the volume of solid. You can look at this animation to understand how this works. You can see the increase in volume, and that increase in volume is the volume of the solid. Now let's understand the difference between two important terms, capacity and volume. On the left side we see capacity and on the right side we see volume. Capacity is the maximum amount a container can hold. For example, this beaker has a total capacity of 100 milliliters. It's filled to the top. You might argue we can still fill a bit more. I agree with you. So the maximum amount this a maximum amount a container can hold is capacity. And on the right side, we are seeing volume. It's the actual amount of space occupied by something. In this case, the liquid inside the beaker. It is the amount that it currently holds. So beaker is only filled up to 60 milliliters. So volume of liquid is 60 milliliters. So in simple words, capacity is about the container, how much it can hold. Volume is about the content, how much it is holding right now. I am repeating this. Capacity is about the container, how much it can hold. And volume is about content, how much it is holding right now. Both are measured in the same units like liters or milliliters, but they tell us different things. So, what did we learn in this session? We learned that volume is the amount of space occupied by an object. The SI unit of volume is cubic meters, and smaller volumes use centimeter cube, milliliters, or even liters. Volume of regular solids like cubes and cuboids can be calculated using formula, whereas volume of irregular solids can be measured using water displacement method. Then capacity is the maximum amount a container can hold, while volume is what it currently holds.